Hi guys, so today we're going to go over log functions. There's going to be two different scenarios you could see. So the first one being that there is only one log on one side of the equal sign, and you can rewrite that in exponential form. So I'm just kind of making up the variables. I know they set variables for this already. So let's say a sub log base a of b equals c. So to write this in exponential form, it would always be base to the other side, so a to the c power equals b. And then if there's more than one log, you're going to condense it. So we'll go over these couple of rules in order to condense it when we get to the example. So notice for the first few problems, you only have one log on one side of the equal sign. So what you're going to do is you're going to take the base to the other side, so 2 to the fourth power equals x plus 1. So 2 to the fourth power equals x plus 1. From here, we're just going to solve for x. So 2 to the fourth power would give me 16. 16 equals x plus 1. And then from here to isolate x, I'll subtract 1 on both sides of the equal sign, giving me 15 equals x. Now, one thing about the log, and you'll see this in some scientific calculators as well, if there's no base, it's automatically a base of 10. So some scientific calculators can only calculate a log base of 10 because you can't input a number other than, well, you can't input any number for the base. So if that ever happens and you actually need to calculate, just make sure you watch the next tutorial, which goes over the change of base formula. But in this case, just know that anytime you don't see the base, it will have a log base of 10. So it would be 10 to the third power equals x. And then we have 10 to the third power, which means there's 3 zeros on the end, so that gives us 1,000. Now, notice here, this is going to be the start of my condensing. You have two options. To get x by itself, technically you could divide by 3, and you'll be left with log of x equals 27 divided by 3, which is 9. And then again, you don't see a base, so it has a log base of 10. So 10 to the ninth power equals x. I will not be writing 9, 0, so we're going to leave this as 10 to the ninth power. Your other option is to condense it, where the coefficients become the exponents. So meaning this 3 times log of x equals 27, you could change the coefficient to become the exponent, meaning log of x to the third power equals 27. And then from there, you can rewrite it in exponential form. So 10 to the 27th power equals x to the third. So remember, we want to get x by itself. The way to get rid of a cube is a cube root or a 1/3 power. Remember, sum and difference of cubes. Whatever you do to one side, you do to the other. So I'm going to kind of write this a little bit clearer. So on the right side of the equal sign, I just have x. Remember, when you have a power to a power, you're multiplying. So 27 times 1/3, I multiply fractions straight across. Fraction form of 27 is 27 over 1. That gives me 27 over 3, which is just 9. So 10 to the ninth power equals x. Notice two different methods, same answer. So that's kind of the intro on if there's more than one log, how we condense. Make sure that the coefficients become exponents. We only write as one log, multiple logs become one, and we do that by changing the adding to multiplication and the subtraction to division. So I'm going to show you in the next two problems here. We're not solving anything, we're just simplifying by using the condensing method. So anything, and you can take it term by term. So for instance, I'll take it step by step, each term separated by plus and minus sign. First thing I'm going to do, I'm going to change any of the coefficients, meaning the variable or number being multiplied to the log function. I'm going to change it into an exponent. So it becomes the exponent for whatever I'm taking the log of. And then for the next term, same deal. This 3 becomes the exponent for what I was taking the log of, which is 2. And nothing happens in the third term, so we'll just bring that down, minus log of k. So in order for condensing to work, make sure that all of the logs have the same base first. They do. They all have a log base of 10 because there's no base there. And now we can condense multiple logs become 1. Anything that is being added, we change to multiplication. So notice that these two terms are being added. We would multiply x to the m power times 2 to the third power. I'll clean that up afterwards. And then anything that's being subtracted gets divided. Again, the multiple logs are just going to be 1. So I'm going to take the log of 2 to the third power is 8, and I'm going to put that in the front as the coefficient, 8 to the times x to the m power over k. So this is how we condense. And for our last problem, we're going to do the same thing. We're going to start off one step at a time. I'm going to take the log of 3x, and that exponent is going to be 7. Now, since I'm taking the log of 3 and x, the whole thing is going to have an exponent of 7. We're going to bring down the minus, and then this coefficient of 2 becomes the exponent for m. And now I'm going to rewrite these multiple logs as 1. And since this is being divided or subtracted, I'm going to change it to division. So it's going to be 3x to the 7th power over m squared. All right, guys, I hope this helps.